Right, this is day 8, meaning the quiz covers 1 through 7. Myself, Miss Venezia, the other honors geometry teacher, went through this quiz and made sure everything from day 1 to 7 is covered. There's nothing that's not covered, I would tell you. All right, I would tell you. So what we did is we broken up your review. You guys see all the theorems here. I'm not reviewing those with you. That's on you. So you see review for central angle theorems. You see inscribed angle theorems we talked about on Friday. If you keep looking down on the theorems, you'll see the chord theorems we talked about. All right, everything will be represented somehow on this quiz. It's 30 points. I forget how many questions. It doesn't really matter. All right, but 30 points, everything will be represented somewhere on some type of question. All right, so there are all your theorems. That's on you guys. I'm leaving those to you. Leaving those to you. Real quickly, let's review. Tomorrow, I'll give you a reference sheet, which has degrees and radian conversions on them. But right now, how do I change a degree to a radian? A degree to a radian. So if you guys flip over your sheet there, go to page 25. You'll see where I'm at right now after all the theorems. So how do I change a degree to a radian? Multiply by what? 8. Degree to a radian. Multiply it by? That's coming up. Pi over 180. We either know it or we know where it is on the formula sheet. Your call. Your call. And then leave your answer in terms of pi when you give me a radian. And we already just went over this, but yep, we multiply by 180 over pi if you want to go from a radian to a degree. Now, please be careful with this tomorrow. I get nervous. Here's why. Let me give you 2 separate radians to convert. 3 pi over 2 and 2.5 radians. Both are radians. What if I wanted to convert them to degrees? 180 over pi, what cancels out? Yeah, the pi's cancel out here. Versus 2.5 radians, 180 over pi. Are you canceling any pi's out? No, don't force it. It may not happen that you cross them out sometimes. So all I'm doing is 2.5 in my calculator times, getting a fraction template out, 180 over pi. And rounding to whatever the rounding directions are. Pi's will not always cancel when you convert to degrees. Arc length, 2 formulas. 2 formulas tomorrow. Arc length. What formula do I use if the angle is in degrees? Angle is already in degrees. What can I use? 21, what formula can I use if it's already in degrees? There it is, if it's in degrees. There's the formula I want. Arc length equals. There you go, measure over 360 times pi d. What if that angle's in radians instead? What formula do I want now if it's in radians? 15.
I forget what it's called, but it's the O symbol.
Theta.
Theta equals S over R.
What's the S stand for in that formula? 18, what's the S stand for?
Arc length.
That's my arc length I'll be asking for, right? That's my arc length. R, radius. Theta. That's your angle in radians. Remember, you do not have to memorize both. Let's say you just memorize theta equals S over R. Well, you better be able to convert any degrees into radians before you use it then. Right? You do not have to memorize both, but if you're only going to memorize one, you got to be able to convert. I have 2 more I need you to jot down. 2 more items here. One formula that's not up there, circumference. What do you got? Circumference formula? 1. Pi d. Now, let's be honest right now. You're in honors geometry. I am not going to give you a problem tomorrow that says, hi, look at this circle. Here's a diameter of 10. What's the circumference? It's too easy for you. Here's what I'll do tomorrow. Here's the circumference. Find the diameter. here's the circumference. What's the radius of this circle? That's what I'll do at an honors level. All right, there's no way I'm going to waste time giving you a diameter just so you can plug it in. All right, so be aware of that. You will use that formula, but maybe given the circumference, give me the diameter or radius tomorrow. All right, and then the other thing to worry about tomorrow, one of these bad boys on there, clock question. Clock question, and this conversion will not be on there. Every time the minute hand, hour hand, second hand goes a tick mark, aka 1 minute. How many degrees is it going? 6 degrees. Now look, this doesn't have to be something magical. You remember, here's how you remember it. Up on the clock, I go from 12 to 12. How many degrees am I going? 360. The clock's broken up into how many equal minute marks here? 60. How many equal minute marks? 60, right? So if I go 360 and they're divided up into 60 even pieces, that's where you get your 6 degrees from. Okay, that's where it comes from. So there'll be a problem involving a clock tomorrow. And I think I put some on the Delta Maths too. Anything you want to ask about the quiz? Okay, I want to make one thing clear. You're about to go on to Delta Math and do a slew of problems. All right, all those right there. Am I saying these problems match your quiz? No, your quiz is going to be tough. All right, this is just making sure you know all the basic theorems, facts, formulas. All right, it's going to be tough tomorrow. You got to be on your toes. I did put a proof on there. All right, there will be a proof on there as well. Anything I can answer for you. I am not checking this. I'm not going to go and see what percent you did. This is on you. It's not an assignment. All right, please call me over if you get it wrong 2 or 3 times in a row. And I need you to work on this by yourselves. Usually, yes, I'd get you into groups and you can do what you want with other people, but not this time. All right, not this time. So let's get going. You can do the Delta Math of problems. You can get a sheet going of everything you need to know for tomorrow. Know your darn theorems, though, please.